Today, I'm going to start one new topic that is Kubernetes. So, in this Kubernetes, we will be learning different topics inside it, where I'll be starting with the basic description that what the Kubernetes is, why the Kubernetes is used, what was it before, what is the basic requirement that why the Kubernetes basically required into the market. So we'll cover all these parts in this complete Kubernetes session series. So I'll be taking this session continuously so that every topic will be covered. So Kubernetes is basically it's a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes service supports and tools are widely available. So this is so in the beginning when there was a Docker, right? And in the Docker, which work on the containers. And the basic issues with the Docker is that whenever we require to start the container when it first stops, then it requires a manual intervention. But over the time, when the Kubernetes comes into the picture, and the container technology that it automatically gets started using the Kubernetes. So going forward, if we look at it, that Kubernetes that originate from the Greek, meaning the helmsman or the pilot. So this is how the Kubernetes it's working, and this is what we can say, like the Kubernetes is a portable, extensible, and the open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes service supports and tools are widely available. So it is open source, and in case if any input is required related to the same, we can get the same from the internet as well, because as it is mentioned that it is the open source. Now, if we see that why the Kubernetes is useful, so basically the Kubernetes we can see that there are the different phases that it passed from. That what we had the previous one as a traditional deployment, and then the virtual deployment came, and then the container deployment. So what is different between all these three deployments? So if we see as a traditional deployment where the, the bare metal was hardware. So what is the bare metal? Bare metal is like on which your the server is existing. So if I say that if a server that is consisting of a RAM, CPU, your hard disk, your processor, and on top of it there is a operating system. The operating system is like your either it can be Windows, either it can be Linux, Fedora, iOS, so any operating system it can be, and on top of it the applications are running. So here the applications, it can be anything which is basically required to run the specific business. So this is the application. Basically, it is on top of the operating system. That is the traditional deployment. Now, why the virtualization is required? Now, if you can see in the traditional deployment, the we have the application which is consuming the operating system resources, right? And sometimes it is like when the some inputs or when some resources are not required and we need to run the another application, then we do have a the resources are fixed. I mean, we can't use the existing resources for the further the other application. And if we check for the virtualized deployment, so for the virtualized deployment, we have the hardware, and on top of it, we are using the operating system, and then we are using the hypervisor. And on top of the hypervisor, we have categorized the same in terms of we have inbuilt the virtual machine, and on top of virtual machine, the operating system, and we have executed the application. So now the hypervisor, which is if I compare it with your local laptop, where the Oracle VirtualBox or the VMware, that is also acting as a hypervisor. So hypervisor, that is after installing it onto the operating system and running the various virtual machines on top of it. So based on the resources that it will consume from the your the base machine hardware and the operating system, but now we have categorized the both the machines, virtual machines, as well as for the in the virtual machines we have the different application on top of it, through which the request is coming onto the applications, and it is going onto the operating system. Now, if we talk about the container deployment, which is the latest the technology, that is the containerized technology, and if you see that we there was a hardware operating system and the hypervisor, which is converted to the which is upgraded to the I could say the container runtime, and container, and on top of it the applications are running, right, container applications, and on the container we have the different applications are running. So this is the container technology, which is currently grooming or too much growing in the market. Now, in the container deployment era, if we see that why it becomes so popular. So why we were using the traditional in the virtualized, but in the container, if we see that we have the application that is running on the container. So if you see that the agile application creation and deployment, that is very ease. We have got a ease on it, increased ease and efficiency of container image creation compared to VM image use. And later on, if we see the continuous development, integration, and deployment, that is also very frequently we can get it from the container deployment. And then if we see for the DevOps separation of concern, where creating application container images and releasing build and release time rather than the deployment time. Therefore, the decoupling application is from the infrastructure is getting more easy and flexible. If we see the observability, so it's not only the surface OS level information and metrics, but also application health and other signals we can get from the container deployment. Also getting ease in the environment consistency across development, then the cloud and OS distribution portability, and then application centric management. And if we see that the resources isolation and the resource utilization. So these are the all benefits that we are getting into the container deployment. So if we move forward, these are the benefits that we have. So that already I described. And if we say that why this is agile? Agile means whenever any of the application, whenever any of the developer who require to run their applications with the different environments. See, someone is using the different language, and someone require the different complete environment. So using the container technology, we have created the container, and on top of it, we have created that environment. And based on it, we have executed the particular code on top of it. And once it is not, once the activity is completed successfully and we don't require any further environment, then we can delete the same, right? So in the similar way, the container technology, we can create the ample of the containers, and the best thing is that the creation and the deletion for the container is very simple, and it's simple as well as taking the less time as compared to the creating the one entire operating system onto the virtual machine. So in the container, it will also provide you the complete environment for the operating system, which we used to get in the virtualized environment. So this is actually making entire thing agile, and it is basically giving very much good support for all these the from the DevOps point of view, where the new ports are building, and we need to have the environment, and we need to release the same so that it can uh, the same can be deployed onto the application, and accordingly the same the end customer can use the application. So if we talk further that why you need the Kubernetes and what it can do. So Kubernetes basically it's the significance. If I talk about comparing to the previous deployments that we had, the traditional and the virtual one. So it's all inclusive of the platform as a service. Since Kubernetes operates at the container level rather than at the hardware level, it provides some generally applicable features common to PaaS, that is the platform as a service offerings, such as deployment, scaling, load balancing, and this basically the users can integrate their logging and monitoring and the alerting solutions with it. However, Kubernetes is not monolithic, and these default solutions are optional and pluggable. So Kubernetes provides the building block for building developer platforms, but preserves user choice and flexibility where it is important. So if we talk about that, what are the why you need the Kubernetes, and uh, why where we can what it can do. So as it is mentioned here, it is for the service discovery and the load balancing. So Kubernetes can expose a container using the DNS name or using their own IP address. If traffic to the container is high, Kubernetes is able to load balance the traffic and distribute the network traffic so that deployment is stable. Now, similarly, it can be used for the storage orchestration. What is orchestration? Where the request is coming on the server, and it is equally distributing into the rest of the server. So Kubernetes allow you to automatically mount a storage system of your choice, and such as local storage, public cloud, and providers, and more. And later we see the automated rollouts and rollbacks. You can describe the desired state for your deployed container using Kubernetes, and it can change the actual state of the desired state at a controlled rate. So basically, if we see the automatic bin packing, you provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. You tell how much CPU and memory each container needs. So Kubernetes can fit containers onto your nodes to make the best of your resources. Self-healing Kubernetes restart containers that fail, replaces containers, kill containers that don't respond to your user-defined health checks, and does not advertise them to clients until they are ready to serve. And the another the benefit that if we can understand is related to the secret and the configuration management. So Kubernetes let you store and manage sensitive information such as password, OAuth tokens, and SSH keys. So you can deploy and update secrets and application configuration without rebuilding your container images and without exposing secrets in your stack configuration. So if we move forward, that what Kubernetes note means, where we have some limitation with the Kubernetes. So Kubernetes, if we see that it does not limit the type of application supported, so Kubernetes aims to support an extremely diverse variety of workloads, including stateless and stateful and data processing workloads. So if an application can run in a container, it should run on Kubernetes. So the first limitation that it told, that it does not limit the type of application supported. And the another one, that is, it does not deploy the source code and does not build your application. So it is the developer who need to deploy the source code and accordingly need to build the application. So continuous integration, delivery, and deployment workflows are determined by organization cultures and preferences as well as the technical requirement. So if we move forward, then it also does not provide application level services such as middleware, data processing framework, database, nor cluster storage system as built-in service. Then it does not dictate logging, monitoring, alerting solutions. It does not provide nor mandate a configuration language system. It does not provide nor adopt any comprehensive configuration, maintenance, management, or self-healing systems. And if we talk about the Kubernetes is not a mere orchestration system. In fact, it eliminates the need for orchestration. The technical definition for orchestration is execution of a defined workflow. First do A, then B, and then C. And accordingly, in contrast, if we understand, Kubernetes comprises a set of independent composable control process that continuously drive the current state towards the provided desired state. So it should not matter how you get from A to C, centralized control is also not required. So if we see that the entire part of the Kubernetes, if we try to summarize that what we understood from these slides. So basically, the Kubernetes, it's the managed and the master node which communicate with the worker slave node. So we have the architecture of the master slave nodes, where the request is coming from the master and it is equally using the load balancer, it is equally distributing it to the worker slave nodes. So if we talk in the Docker world, which we had, we use the word container, but in the Kubernetes, it asks container to launch application which is managed in one box, that is pod. So these in the Kubernetes, these containers are present inside the pod. So in Docker we use container, but in Kubernetes we use pod, which has container inside it. So the pod is, I mean, this is the basic in the Kubernetes. So whatever we will be trying to create any application or create any the container, that will be created inside the pod only. Now, if we try to understand the some of the basic uh, query that comes in, that what is Kubernetes. So after going through with this slide, we can understand that Kubernetes, it's a portable, sensible, open source platform for managing containerized workloads and services that facilitate both declarative configuration and automation. And if we try to understand what are the benefits of using Kubernetes, so control and automate deployments and updates, orchestrate containers on multiple hosts, scale resources and application in real-time test, and auto-correction of application. And if we talk about that, on which architecture does Kubernetes work? So Kubernetes work as on the master slave architecture. Now, if we say that what is the multi-node cluster and single node cluster in Kubernetes? So single node that is the many-cube, and multi-node cluster consists of the one master node and multiple slave nodes. So this is difference between the single node and the multi-node cluster. Now, what do you mean by pod in Kubernetes? So pod is the, now we can say after going through with these slides and having understanding that pod is the smallest unit in Kubernetes which can contain single or multiple containers. So in this way, we can conclude the today's session, and through which we learned the various part of the Kubernetes, as the why Kubernetes is used, what is Kubernetes, what are the benefits, how the architecture is used, multi-node cluster, single node cluster in Kubernetes, and what is the meaning of pod in Kubernetes. So we will learn further thing in our rest of the sessions. So this is all for today. Thank you so much for listening this session, and I hope the journey for the Kubernetes will be very fruitful. Okay, thank you all.